So hello guys, today we have Leetcode questions today, and we are going to understand the questions answer. The first question we have here is the 872 and leaf similar trees, and in which the condition is saying that consider all the leaves of the binary tree from left to right order, and the value of those leaves from the left from a leaf value sequence, right? Leaf value sequence is just what means we have to check that all the values should be matching, right? The values should be uh, exactly equals in the sequence. So the answer is like two binary trees consider leaf similar if their leaf value sequence is the same, and it will return if and only if the two given trees and leaves node root 1 or root 2 are similar leaves, right? And that's why we have given two root here, right? In the program you can see root 1 and root 2. Before going to the solution, we will understand the example first. So as example first, we have given this tree and this tree, in which we have root 1 is given, this one, and root 2 is given. So all the nodes are given here, as you can see that, and we are comparing this, and we will return true. Now you can see this example 2, in which we can see that two tree node is given and leaves are here. So that just exchanging the node value, right? The leaves value, and you can see that 1 2 3 and 1 3 2 both are not equals, right? And that's why it is called false. So how we will calculate this one, right? How we will calculate that this is right or wrong? As you can see here, what we have 3 5 1, right? And 5 have children what 2. So now we will see that this calculation, right? This calculation 6 5 7 6 5 7 is what I think 17, and 9 8 is what 9 and 8 is what 17, right? Now we are doing that like the 1 3 and 5 will remain same, right? But 6 and 7 of children 2, 6 and 7 of children 2 will come what where here in the 5. Now 5 have 6 will remain same, but this node is completely going, right? This node is going here, so 7 will come because 2 is going from here. So 7 will come where at the place of 2 here, and 1 is coming to what in this position, right? This position, sorry, 4 is coming to this position, right? And the 2 will come to now here at the point of 2 8, right? And 9 8. So now if you calculate this one 6 7 4, the 6 7 4 it remains same. 6 7 4 previously coming, now it is coming 6 7 4. The sequence is not changing, and 9 8 will remain same in the last. 9 8 remains same. It means the position of the sequence, right? The all the leaves nodes of the position should not be get changed, but here it is changing, and that's why we have to return true or false. If we make the list of this, so this will be the list, right? And this will be the list, right? And that's why the list is not changing, and that's why it's easy the code. And we can see that the leaf similar trees, what we have to do, we have to take at least what at least two you can say a list, right? That contains you can say that contains the all the leaves, right? So what will I do here? I will start from creating a list. Okay, so I'm starting list, and then the list is what of type integer, because we have integer data, right? Integer. And this is no, we can make it as leaves. Okay, leaves 1 and equal to new array list we can take. Okay, array list, because we are making list. Okay, so this is first leaves, first tree will contain this all the leaves. Okay, and leaves list 1 you can say that, or leaves 1 or leaves 2 you can say that. So I'm creating another, second is also done. And now what we have to do, we have to do very simple things, right? That we will create a DFS utility, DFS utility method, DFS utility method, and that method will take the root 1 dot leaves 1. Okay, and another we will take what similarly leaves 2 leaves 2, leaves 2 and leaves 2 and root 2. Okay, because we have to traverse both nodes, right, both tree. And then finally we will check the return. We will do leaves 1 dot equals, right, leaves 2, and whatever the value we have here we will return that. Okay, and in between that what we should do here is that we'll create a DFS utility method now, and that should be void, and the name should be DFS utility only, and it should contain what, tree node, right, tree node. This will take tree node, and this integer array. Okay, what it will take, leaves list of integer, and that will call leaves, right. What we have found here is that we have to create one we have to do first, we will make a condition to check that if the root should not be what, rather than root we will take a node. Okay, to understand, we will take node should not be equal to what, null. If this is null, we do not need to do anything. Sorry, we do not need to do anything, we will return from directly, right. So if the condition is that node is not equal to null, then we will check node dot left, right, and we will check equal to null, or will to check to null, and node dot right equal to null. We have checked both, right. Now in this condition we will add, right, leaves dot what, leaves dot add, correct, add method, and then we will add the node value, right. And similarly we will continue this DFS internally, it will call its children, right, 2 times it will call its, this will be your node dot left and node dot right, and leaves will be leaves. So all the children will get updated here into the list, right. Now I think we are done, so we have almost done everything. Let's understand one more time what we have to do. We have taken leaves 1 and leaves 2, and both will contain its children, right. So root 1 we are passing here, and leaves 1, and root 2 and leaves 2. Now we will do leaves 1 dot equals leaves 2, and this DFS method we will call, in which we will pass node and leaves, in which we have to add all the leaves. What we have to do, we will check node should not be equal to null, and then left or right is equal to null. Then what we will do, we have to add the parent, the node dot val into the list, and then we will traverse left and right, all the nodes will get added into the onto the list, right, one by one. Now let's yeah, it's working. So let's continue to understand what I have did here. Equal. So in this approach we will go through the first DFS, and we will understand the induction of an algorithm. So let's find the leaves value sequence for the given trees, and afterwards we can compare them to see if they are equal or not. So to find the leaves value sequence of a tree, we use a depth first search, and our DFS function writes the node's value if it's a leaf, and then recursively explore its child. And this is a guaranteed to visit each leaf in the left to right order, as left children are fully explored before right children. So we have seen already that the function is containing two nodes root 1 and root 2, and we have to return boolean value. Okay, so we have to take first two node, right, leaves 1 and leaves 2. That should be a type of array list, and we will traverse first root 1 and then root 2 with the leaves, and we will add all the value over leaves 1 and leaves 2 of the its leaves. Okay, and then we'll finally compare leaves 1 and leaves 2, and whatever the value we have, true or false, it will return to as an answer. Now the best part of this function is DFS utility method, in which we have to pass DFS node and left and right, node value left and right. So if node not equal to null, what we have to do, we have to compare, it should not be null, right? Then we will check left and right is null, means it is orphan child. This is the leaf, and the leaf should leaf node should have the value, and that value should be added to leaf values, right, the list, right? And we have DFS node node dot left and node dot right. So we will traverse for after adding each what you can say, its children's, right? If parent is run, then we have to move to leaves, then right. In that manner we will traverse all the nodes, and we will return the true or false, it is true or not. So time complexity is what we have two nodes T1 and T2, in which T1 and T2 the length are almost similar, and time complexity will remain same. So T1 and T2 are used to store the leaves. We are taking two extra spaces, right, this one, to store this one. So this will be the answer, and please let me know if any doubt you have, and please like, share and subscribe our ExpertFunda. Thank you so much to be here.